Assalamualaikum warahmatullahi wabarakatuh. First of all, we would like to express our special gratitude to our beloved lecturer, Ms. Nur Fatihah, who gave us this golden opportunity to do this project on the topic Techniques of Differentiation. We also sincerely thank our lecturer of Calculus 1, Ms. Nur Fatihah, for all the guidance and willingness to help us completing this assignment. This assignment is impossible to be done without the help of Ms. Nur Fatihah and the amazing cooperation and effort of our group members.
Let me show you answer for question 1. What is differentiation? Differentiation is the rate at which one quantity changes with respect to another. For example, speed is the rate of change of distance with time. The speed at any instant is not the same as the average speed because it represents the slope of the distance time graph, which show how fast the distance is changing at the moment. In general, differentiation refers to the ratio of a small change in a quantity to a small change in another quantity that depends on it. In calculus, differentiation is used to find the maximum or minimum value of a function, the velocity and acceleration of moving object, and the slope of a tangent that to a curve. If y equal to fx is differentiable, its derivative is written as f prime x or dy over dx. Next, I will show you the 7 differentiation techniques and their formula. First, constant rule. Constant rule is the derivative of a constant is always 0. Second, power rule. Power rule is used when the function is variable raised to a power. Third, sum and difference rule. And difference rule is differentiate each term separately. Next, product rule. Product rule is used when the functions are multiplied. Then, chain rule. Chain rule is used for composite function inside function. Next, quotient rule. Quotient rule is used when one function is divided by another. Lastly, constant multiply rule. Constant multiply rule is if constant multiplies a function, keep the constant and differentiate the function. Let me show you the answer for question 2a. In this question, we use the chain rule and the product rule to solve the differentiation. First, we look at the function y equals tangent of x cubed times e to the 4x. Since the tangent function has another expression inside it, we must apply the chain rule. The chain rule tells us that when we differentiate tangent of something, the result becomes secant square of that same something times the derivative of the inside expression. So, when we differentiate the tangent, it becomes dy over dx equals secant square of x cubed e to the 4x times the derivative of x cubed e to the 4x. This shows how the whole expression x cubed e to the 4x move from inside the tangent into the secant square because the chain rule always keep the inner function inside the outer derivative. Next, we differentiate the inner function x cubed e to the 4x. This is a product of x cubed and e to the 4x. So, we use the product rule and then let u equal x cubed u. So the derivative r becomes u prime equal to 3x squared and let v equal e to the 4x and the derivative r become v prime equal to 4e to the 4x where v prime use the chain rule again because of the exponent 4x. Then applying the product rule give d over dx of x cubed 4e to the 4x plus e to the 4x 3 square. Lastly, we substitute this result back into the chain rule expression. This gives the complete derivative dy over dx equals secant square of x cubed e to the 4x times the quantity 4x cubed e to the 4x plus 3x square e to the 4x.
Next, let's take a look at answer for questions 2b. You may refer to question 2b that has already been included in the problem statement. Fx equal to 3 minus 4x over ln 2x. This kind of question requires us to use quotient rule, which is vu prime minus uv prime over v square. Next step, we need to differentiate u equal to 3 minus 4x and we get u prime equal to negative 4. Then differentiate v equal to ln 2x and we get v prime equal to 1 over x and apply the quotient rule in f prime x equal ln 2x times negative 4 minus 3 minus 4x times 1 over x over ln 2x squared. Then the final answer we get f prime x equal to negative 4 ln 2x minus 3 over x plus 4 over ln 2x squared.
Next, let's take a look at answer for question 3. Step 1, we need to separate the 4 expression into a plus b minus c equal to d to make it easier to differentiate. Step 2, we need to differentiate a. A is x squared cos y, so we use the product rule for this equation. A equal to x squared and then a prime equal to 2x. So we got cos y and the derivative of this is minus sin times dy dx. So a prime become 2x cos y minus x squared sin y times dy dx. And then next, we differentiate b. B equal to ln x over y. So we got b prime equal to ln x minus ln y. So b prime equal to 1 over x minus 1 over y times dy dx. And then we differentiate c. C equal to negative 2x, so we got c prime equal to negative 2. Next, differentiate d. D equal to exponent the power of 1 minus 2x. For this equation, we use chain rule, so we got exponent to the power of 1 minus 2x times negative 2. So d primes equals to negative 2 exponent to the power of 1 minus 2x. Step 3, we combine everything, which is 2x cos y minus x squared sin times dy dx plus 1 over x minus 1 over y times dy dx. Minus 2 equals to negative 2 exponent to the power of 1 minus 2x. Step 4, we need to group all the dy dx terms together. So we got negative x squared sin times dy dx minus 1 over y times dy dx. And the rest of the terms, we move it to the right side, and so we got negative 2 exponent to the power of 1 minus 2x minus 2x cos y minus 1 over x plus 2. Step 5, dy dx equal to negative x squared sin minus 1 over y. And we got negative 2 exponent to the power of 1 minus 2x cos y minus 1 over x plus 2. So the final answer, we got dy dx equal to negative 2 exponent to the power of 1 minus 2x cos y minus 1 over x plus 2 over negative x squared sin minus 1 over y.
Alright, now let's continue with the last question, which is question 4. So for the step 1, we start by letting x naught be 64 and x be 64.02. So the change in x, which is we call delta x, is x minus x naught, and that gives us 0.02. The function given, f of x equals 2 over the cube root of x plus ln of x. Now we find f at x naught, which is f of 64. The cube root of 64 is 4, so 2 will divide it by 4 give 1 over 2. Next, we look at the ln of 64. 64 is the same as 2 the power of 6. So the ln of 64 is just 6 times ln of 2. Step 2, find the derivative f prime of x and f prime of x naught. So the function will become 2x to the power of negative 1 over 3 plus ln of x. So the derivative is negative 2 over 3x to the negative 4 over 3 plus 1 over x. Now we will evaluate this at x equals 64. And we will get 5 over 384. For the last step, we are using the formula, which is linear approximation formula. F of x is approximately equal to f of x naught plus f prime of x naught times delta x. And we will get f of 64.02 is approximately 1 over 2 plus 6 times ln of 2 plus 5 over 384 times 0.02. You'll get approximately 4.6591 to 4 decimal places.
In conclusion, we learn differentiation to understand rates of change, and it helps us to solve real-life problems. By working with the group project, let us work together and brainstorm together. Second, we can apply differentiation to everyday situations such as calculating how fast something moves, managing money and economics, and making smarter technology.